Okay, we're going to go through a comprehensive review of factoring today. So I've made a handout for you. The handout is posted in Blackboard within the Module 3 folder. You're going to make sure that we remove our common factors first. And then we're going to look at the number of terms present. If there are 3 terms, we have a trinomial, and we will use the product and sum method to factor that trinomial. If there are 2 terms separated by a subtraction sign, we will either have difference of squares or difference of cubes factoring. The numbers will be either perfect squares or perfect cubes. The exponents will either be divisible by 2 or divisible by 3. Lastly, 2 terms separated by an addition sign will require the sum of cubes formula. There is no such thing as sum of squares factoring. Okay, let's get started. We're going to do 8 problems together. Okay, question 1 is certainly a trinomial. There are 3 terms here. So we're going to begin by multiplying 12 by negative 40. We're going to use negative 17 as the appropriate sum. So we want 2 numbers that we can multiply to give us negative 480. The same 2 numbers, when added, should give us negative 17. And here, you may take a few minutes to come up with the numbers. So in this case, for example, if I take negative 480 and I divide it by 20, I get negative 24. But the 20 and the negative 24 will not give me a sum of negative 17. And it's only once I try 32 or 15 that I would stumble upon the right combination. So negative 480, if I divide by 15, would give me negative 32. These numbers here have a sum of negative 17. And don't despair, sometimes it'll take you quite a few minutes to come up with the appropriate combination. Okay, so once I have the numbers correct, I replace the middle term here. So it will be negative 32x followed by positive 15x. Now we use grouping like this. We remove the common factor from the first 2 terms. They are both divisible by 4x. When we divide by 4x, we will have 3x minus 8 here. From these last 2 terms, we would remove positive 5 as the common factor. Once divided by positive 5, we will again have 3x minus 8. This, of course, has to happen if we've done it correctly. So that 3x minus 8 is one factor. The other is found here, 4x plus 5. And that was a tricky or general trinomial because the leading coefficient was not 1. So it's a bit of a lengthy process. Here's a second example. This time we have 2 terms. They are separated by a subtraction sign. So this will be either difference of squares or difference of cubes. This one or this one. 2 terms, subtraction sign. And this is dependent on the numbers. Are they perfect squares or perfect cubes? These numbers are perfect squares. So we can start, if we like, by writing them as perfect squares. So now we take the square root of 144, which is 12. The exponent here is divided by 2. we take the square root of 49, which is 7. And now we have A and B determined. And we can write A plus B, A minus B as our answer. So that'll look like this, A plus B, A minus B. And that's example 2. Here's another one. It's very similar to the previous example in that we do have two terms separated by a subtraction sign. But these numbers are not perfect squares. The square root of 343, for example, is a mess. They are, however, perfect cubes. So what we do is change the setup. So instead of exponents of 2 outside the bracket here, we put 3's. And then we work out the cube root of 343, which is 7. Also, the cube root of 27 is 3. And for the exponent here, the 6 is divided by 3 to give us a 2 inside the bracket. So A is 7, B is 3y squared. So that's A cubed minus B cubed. So now we're going to follow along with this formula. So we're going to have a binomial followed by a trinomial. So a binomial and then a trinomial in our answer. So the binomial is just A minus B. So here that is 7 minus 3y squared. Now let's work on the trinomial. First, we have to square A. A is 7, so its square is 49. We take the sign from the formula, plus. This is AB, which means A multiplied by B. So we will multiply 7 by 3y squared to get 21y squared. We take the sign from the formula. Now we have to square B. We have to square the number 3 to get 9. When we square y squared, we will get y to the power of 4. The exponent is doubled. Okay, so that's the perfect factored form for number 2. So again, difference of squares for number 2, difference of cubes for number 3. Okay, number 3, a trinomial. Remember to remove all common factors first. So, in fact, these numbers are all divisible by 6. So we will remove 6. Not only that, an x is common to all terms. So let's take 6x out of the terms, which means dividing them all by 6x. This will give us x squared minus 14x plus 45. This trinomial must be factored. Now, the good news is the leading coefficient here would be 1. This is an easy trinomial, which means the factoring is quick. We know there will be an x here and an x here. We want two numbers whose product is 45. That's the same, of course, as 1 times 45. Oh, excuse me for a sec. The same two numbers have to have a sum equal to negative 14. So these are nicer to work with, certainly. the numbers themselves will be -9 and -5. And so those numbers will go here and here. And this is our factored form for number 4. Okay, so after removing the common factor, we just factor the trinomial using the product and sum method. The method is easier in this case because of that leading coefficient of 1. Okay, let's try our next problem. Okay, as with the previous question, we look right away for a common factor. Certainly we can see x present and y present in each. You can only take out one x and one y. You have to take out the smallest exponent that's present in both terms. So we'll take out an x, we'll take out a y. Both of these numbers are also divisible by 5. So let's remove 5xy using division. Dividing this term by 5xy gives us 25x squared. Dividing this term by 5xy gives us 121y squared. Two terms, subtraction. Do we have squares or do we have cubes? Probably you recognize that these numbers, 121 and 25, are perfect squares. The exponents certainly are a big clue here. These numbers are both 2's, indicating difference of squares. Okay, so for the a and b, we of course use the square roots of these things. So 5x is a, 11y is b, okay? Because we could first, if we like, write it like this, with a 5x here and an 11y there. A, B. And then we follow up, of course, with the difference of squares formula. So we're going to have a plus b, a minus b. Like this. A plus b, a minus b. So you can see this term really, this line rather, is optional. It is possible certainly to go right from here to here. Okay, same thing back here. If you have this expression and you would like to go right away to this final answer, that's perfectly appropriate. Okay, let's go on and try a 6th problem. Okay, so here we go. Problem number 6, 3 terms. We're definitely going to use the product and sum method. Is there a number that divides into 42, 29, and 5? There is not, other than 1. So we're stuck with the numbers as they are. This is a tricky trinomial or a general trinomial. Not an easy one, so it's a fair amount of work. We start by taking 42 and multiplying it by -5. That's -210. We want the sum of the numbers to be 29. Okay, so we can see here that we're going to have one positive number and one negative number in order to get a negative product and a positive sum. So you would start by dividing -210 by things, hoping to get a sum of 29. For example, if I started with dividing this by 10, I'd look at the 10 and the negative 21, and I'd see, oh, I did not get a sum of 29. So, you could try this again and again until you hit upon the correct combination. In this case, you might get that correct combination after trying 6, and you'd say, oh, how about a 6 and a negative 35? Well, that actually would give me negative 29 for a sum. So perhaps if I switch these using a negative 6 and a positive 35, I will have the right numbers. So negative 6 times 35, yep. And negative 6 plus 35 also works. Okay, so these are the correct numbers. And a reminder that you can put them in here in either order, this number first or this number first. So I'm going to do the negative 6 first. I have to make it a like term, so it will have an AB on it. Then we'll have the positive 35 also with an AB on it. Okay, now we do our grouping. From the first two terms, what is the largest common factor? 6a. If we divide by 6a, this will be 7a minus b. Common to the last two terms are positive 5 and also b. If we divide these terms by 5b, we will get 7a minus b. Okay, you can check these, of course, by opening them back up using multiplication to see that you get this back, right? 42a squared minus 6ab plus 35ab minus 5b squared. You get it back. This is the match we were looking for, making 7a minus b the first factor. The other factor is 6a plus 5b. Perfect. Expand it out using multiplication. See if you get back the original, and you'll know that you can use that as your check every time. Okay, 2 more examples. Number 7. Always common factor first. Certainly these are divisible by 2, but not only that, they are divisible by 4, they are divisible by 8, and they are both divisible by 16. So you have to take out 16, the largest common factor. Dividing by 16 gives us 125r cubed plus 27. This is the first time we have two terms with a plus sign between them. There is no choice. If it's factorable, we will have to use sum of cubes. So we can write this step in first if it's helpful to us. We put the 3's here, and now we take the cube roots of these things. Right? So the cube root of 125 is 5. So we need a 5 here. This is r cubed, so in here must be r to the 1. Okay, because then 1 times 3 would give you back the 3. The cube root of 27 is 3. And this means a is 5r and b is 3. We use the formula now. We will have a binomial followed by a trinomial. Binomial, trinomial. In fact, all the signs can be taken right from the formula. So there will be a plus sign here. And then here, we will have a minus sign and then a plus sign. Okay, so now we're going to fill in around those signs. So here should be a plus b. So 5r plus 3. 5r plus 3. To start the trinomial, we need a squared. You must square 5r. That means 5r times 5r, 25r squared. The middle term is a times b. So multiply here to get 15r. Lastly, we want the square of b. Squaring 3 gives you 9. Okay, so that's example 7 complete. Last one. One more trinomial for us. Is there a common factor? I know you are all nodding your heads. These are all divisible by 5. So we remove the 5 first. Here's the trinomial. It is tricky, it is not easy. General trinomial because this is not a 1. That means it's going to require some steps. 5 times negative 2 is negative 10. We use the 9 here. What two numbers have a product of negative 10 and a sum of positive 9? 10 and negative 1. This means we replace the middle term here of positive 9x with positive 10x, negative 1x. Okay, so we replace the middle term. X is the literal part, and 9 is replaced with the positive 10 and the negative 1. Now we do the grouping thing, right? So I would suggest that here you're going to change up the bracketing maybe just to help you. So what's common to these two terms? 5x is common. Dividing them by 5x will give you x plus 2. What's common to these last terms? If we just take out 1, we would not end up with x plus 2 in the bracket. We need to take out negative 1 so that we do end up with positive x plus 2. Okay, remember you can check these by expanding to make sure you get the previous line back. This is what we needed. That matching binomial, which is one of the factors. The other one is here, 5x minus 1. Okay? All right, so we had a good variety today in the 8 that we looked at. In fact, if we just